1, which is all the basics of computing, cloud computing, and basics of AWS. And if time permits, we'll bleed into learning S3, a few practical things on S3, and a few practical things on S3, and some theory on S3. I think yes, Amit wants a watch group. I think it's possible, but we'll have to check with Irshad. Let me check with Irshad on that. All right. So databases. Databases, there are 4 components specifically we'll have to know in databases. I mean, there are 4 components in database, but we'll be learning 3 of them. RDS, DynamoDB, Elasticache, and a little bit about Redshift, just enough about Redshift to know what that does and all that stuff. Redshift is majorly covered in the Big Data Specialty exam, where we talk a lot about Hadoop, data warehousing, and Redshift clusters and all that stuff. But in the associate level, we talk about these 3. That's what is needed for the associate level exam. All right. So what are the different types of databases available? They are RDS, Relational Database Service, and SQL Service, and then NoSQL Service. There are 2 types available on Amazon. So what's the difference between them? Number 1, this database is fully managed by Amazon. Right? It runs on a server, which is very right. It runs on a server, and the server is fully managed by Amazon. The patching, rebooting and all that is taken care of by Amazon, and we get to use the software that's installed on that machine. So we get to install all these databases in a server. The server is not in our control, but we have full administrative control on these softwares. All right. So this would be a platform as a service. So we buy this platform, and we get to manage them. It definitely runs on a server underneath. We get to manage this platform, right? So the platform, right? So it definitely runs on an EC2 underneath, but this is fully managed by Amazon. All right. If this goes down, Amazon brings it up immediately. Right. The data that we store in the database, they are saved by Amazon. All right. So these are all some additional features we get to buy, and we get to use them as platform, as a service. All right. So that's one. This is for SQL type database, relational or SQL. All right. And the other one that Amazon provides is DynamoDB, which is of NoSQL type. Let me quickly show you that as well. And this is this class is all about a little bit of introduction about the different types of databases available. We will talk about them in detail when we talk about databases in AWS in Chapter 7. With RDS, Relational Database Service, we buy softwares, like I showed a screen. We buy softwares like Oracle, Aurora. There are different types of DBs available. We buy them, and we use them, right? In NoSQL, there is no buying software, this, that, and all that stuff. With NoSQL and Amazon, we directly get to interact with an application. The underlying is run by Amazon, and on what it is running is hidden from us. We only get to use, we only get to create tables and sort of use them. All right. So they fall under different use case strategies. Right. One is the other one is SQL, and this is NoSQL. Number one. And number two is, if we are really looking at a cost-effective solution, one would pick NoSQL database and go with creating tables and pay only for the data that is stored. All right, nothing to do with the commercial softwares like Oracle and a couple of others that we saw. All right, so when we go for the other one, RDS, we pay for the software on an hourly basis, definitely. All right, and then we pay for the data stored, and data retrieved. Yes. But here in NoSQL type, we only pay for the data stored and data retrieved. The software per hour is taken away. All right. So as architects, depending on the type of workload, we will be picking the right one. And again, we will discuss a lot about these when we in Chapter 7 when we specifically talk about different databases in Amazon. All right. There's another thing that we saw. I'm not sure if that's right. Elastic Cache. Yes, it's here. The other thing that we saw is Elastic Cache. So what's Elastic Cache? I mean, by the name, we can sort of guess what it could mean. It definitely does caching. All right. So what's Elastic Cache? Let's say I have a DB here. All right. DB performance is measured on basis of input, output per second, IOPS. All right. Input, output per second. All right. Let's say my database is read intensive. All right. The data that I have is read intensive. Let's say this is an article that I'm publishing. All right. Article I'm publishing using this database. So I would just update once. Worst case, 10 times in a day. All right. That's how much update I would do to this article. All right. But the reads could be 1 million. All right. Are they all reading the same? I mean, are they all performing a different action the whole 1 million time? No. They all perform the same action. They all read the same file the same way 1 million times. All right. So, I mean, how is that relevant to IOPS? We have to buy IOPS in advance, just like we tried that with EBS, right? We'll have to buy IOPS in advance. So similarly with RDS, we'll have to buy IOPS in advance. And IOPS is really used effectively if I use it to use it for different type of calculations or different type of workload. For the same type of workload, wasting IOPS is not a wise thing. So what I would do is, or what we can do in cloud is, it has given us a facility to cache the data away from the database. All right. So cache the data away from the database, and this is pretty cheap. All right. Cheap than storing a lot of data on DB and having customers read and waste IOPS. This is pretty cheap. Having an memcached away from the database and directing all the 1 million requests to here, and only the writes goes to the actual database and reads are all directed to the memcache. All right. So that's a very surface level introduction about memcache. When we talk about when we talk about this in the chapter, we can create a file in a database and try to read it, and then later we can create offload the reading to memcache and try to read the information, and we can see that or see or experience that it's a lot faster than reading it directly from the database. All right, that's something that we will try. All right, so that's about database. A little bit about management tools. All right, CloudWatch. Sometime back, somebody opened up a topic about CloudWatch, and we discussed a little bit about CloudWatch. All right, so again, just to recollect, CloudWatch is a monitoring tool that works well with EC2, also works well with a lot of other services in the cloud. Just like the way you're seeing it, CloudWatch gives us the metric in a graph format Visually it gives in the graph format, but the data is stored as logs in general. All right, that's how they are stored. So we can use CloudWatch to trigger alarms. If there is a spike for more than 5 minutes, let's say, we can use CloudWatch to trigger an alarm. And if anything goes below a certain limit and it stays there, it's here. All right. So if anything goes below a certain limit and stays there for a while, just like I have highlighted here, you see my mouse pointer, an alarm can also be triggered to look into the issue, or an alarm can be triggered to reduce the capacity because it's past 9 p.m. in the night and the usage has really gone down, or it's a weekend, the usage has really gone down, things like that. So we can use CloudWatch for that. CloudWatch really works with a lot of other services in Amazon. All right. Another cool thing about cloud is a product about cloud is cloud formation. All right. Let's say I have an environment with a server farm, with a DB farm, right, and they talk to each other and all that stuff. I have specific IPs for them. All right. Everything is going well. It's a bright, shiny day. Things are awesome. But suddenly, my project is taking a break for 3 months. All right. Ideally, I should not be running these systems for 3 months due to budget and a lot of other reasons. So I would take an abstract, right? Take an abstract in JSON format. Now let me quickly show you how that is going to look like. Let me throw NAT gateway. That should also work. All right, so I'm provisioning in instances here. If you see, simultaneously something is getting written here simultaneously. All right, so I can, it's here. So something is getting written simultaneously. This is nothing but my infrastructure in a code format. Now, this infrastructure needs a lot of working in it. The things needs to be connected using using pipes and all that stuff to really create an infrastructure. But what I just want to show you is that anything that you do to your infrastructure behind the scenes, they are getting saved as an abstract in JSON format by default, and I can save the template. All right, I can save the template, and after 3 months, when I'm ready, when my project is going to go live, I can use the template and reprovision the exact same infrastructure with zero difference. All right, so that's something I can do using cloud formation. It's a really good tool. Now you might have heard of infrastructure as a code. It's IAC, infrastructure as a code. This is what they mean, infrastructure as a code. So create an infrastructure, take an abstract from it, and save it. We can use the same infrastructure for provisioning multiple environments in different places. Let's say I worked for a company which had 120 locations worldwide. All right, and in each location, the type of configuration is almost the same. Even if I go and I need to have a broad category of the type of environment that we provision, I can put it in 3 different categories. So 120 different sites, I can put it in 3 broad categories. So how is that relevant is I can take this code and reprovision another environment. Let's say we're coming up with a new site, right? Let's say that's 121st site, and that definitely is going to fit in one of these. So I can take an abstract of this configuration and reprovision and a new place, a new DC there with almost instantaneously. All right. Initially when I built this for the first time, this probably would have taken me like few days, maybe to put everything together and build this environment. But now, because I have an abstract, because I have this infrastructure as a code, I can use that code and run it in CloudFormation, and that would build the exact same infrastructure in another place with almost instantaneously. All right, so that's something that's possible with AWS. All right, that's called CloudFormation. And then we have CloudTrail. Right. Sometimes people get confused with CloudWatch and CloudTrail. If you're not giving enough thought, it might look the same. But like I said, that's only if you're not giving enough thought. But if you look deep, they are different. So the other one is called CloudWatch. That's to monitor, all right, monitor ups and downs in the environment and then trigger alerts. And CloudTrail is only to save the logs, all right? Save all the API calls and save the logs in cloud. Save the logs somewhere in the cloud. Like, so what are all the things would it save? The API caller, the username of the caller, like you see here, and then the time the call was made, and then what type of API call was made. Was it an HTTP read request or write request, and all that stuff. And then the source IP of the caller, right? From which IP is the person trying to connect to us and all that stuff, right? You should be familiar with server logs, right? So if anything goes wrong with the server, we quickly log in to the server if the server is still online at that time, and then we would sort of check it, right? So that's only if the server is online. If the server is not online, we get to lose the logs, right? So we came up with remote logging, where we sort of run a server separately only for logging, and run a server separately only for logging. So let's say this is a production server, and this is a remote, right? Remote log server. So all the logs will be sent here, and this will have a storage where it sort of saves the logs, and we need to log in remotely, and we need to use a tool to query and look at those logs. Looks sort of tedious, right? CloudTrail, it simplified everything. It's again an application as a service. The underlying thing is all maintained by Amazon, and we only get to use the surface, or we only get to use the GUI and get benefited out of it. All right, so this is application as a service. So that's a little bit about CloudTrail. So I'm an architect in a company, and I have like 500 users in my organization, and I can put them in different categories, like, you belong to training, you belong to production, you belong to development, and you fall under this role, a lead role, or an escalation lead role, or an engineer role, whatever. All right. So security, in other words, IAM, Identity Access Management, is what really helps me to manage all those 500 or even 1,000 users. So here is where we would create new users, and let's give this user a custom password. And then there are, like I said, there are two ways we can interact with Amazon. I'm going to give this user access only to the console. I can also give access programmatically accessing the environment. So it can be both. It's not like one or the other. It can be both at the same time. What was that? It said you must create a new password at next time. No, not needed. And then I can define which permissions to give this new user that I created. Let's see. Here are some permissions that are already listed. You can be admin. Admin says that provide full access to AWS resource and AWS services and resources. I believe we have one called Power. Yes, Power User. It's little different. Power User has full access to AWS resource, but does not allow management of users and groups. They can sort of use all the resources. They have full access to the resources, but they don't have control on the on managing another user. You know, what he gets to access, this, that, and all that stuff. All right. And then read-only. There are a lot of read-only services that are available. Let's say, you know, a new person joined in the team, and you want to restrict access only to read-only for that person because he's new and he's so curious he could sort of try to play with things and has the potential to break it. We can give that person read-only for the first week or 2 weeks maybe, and then when we see that person is really comfortable and we get the confidence, we can move that person to the next level of credentials. So that's something that's possible. That's using IAM. Again, this is something we will discuss separately in detail. We can try giving access to one person to one service and not give access to the other service, and try to run things and get to see how that errors out or how that's working if the person is given access. All right. So that's about security and identity. We can create users, groups, and sort of manage the account. Right. We can also use a directory services in the cloud. The cloud environment is no different than our traditional environment. Everything that we do in our traditional environment can definitely be done in the cloud environment. And also there are a lot more that can be done in the cloud environment. Right? So one cool feature is the ability to have directory service in the cloud. I mean, everybody who are used with the AD services in their local environment can get themselves familiar with AD services in the cloud. It almost looks the same, except for the fact that it's in the cloud. All right, so it's the same way. Number one. Number two, I can integrate my on-premises AD server with the cloud infrastructure. That way, I don't have to have two AD servers. That's one thing. And by integrating AD servers, on-premise AD servers with the cloud, I don't have to create a new username and password for the resources in the cloud. If somebody wants to log in, I mean, let's say a company has got resources both in the cloud environment and in the local data center. So without AD integration, what would happen is they will have to use their own username password locally, and then they'll have to use some own in the local infrastructure and AWS. They'll have to maintain two username and password. But if I can integrate my AD, that's right, single sign-on. If I can integrate my AD, I can use the same username and password I used to log into my laptop. Right? Both for resources in the organization, within the organization, and for resources in the cloud. So that's called single sign-on. All right, so not only that, we also have a couple of other features like this one, a transcoder. If we are an video publishing company, let's say, and let's say we run YouTube or something that's equivalent to YouTube. Let's say it's Hotstar. Right? We run Hotstar, and our users publish the videos from whatever format that's available in their cell phone. Let's say, all right. So I can have a transcoder service. This is again a platform as a service. So I can use this service, and anytime somebody uploads the data in an S3 bucket, I can have the transcoder take the data, sort of convert it to be viewable in Android Apple laptops and desktops, they all run on different formats. So make it readable in those formats and save them in different bucket or in the same bucket with a different format. So that's possible without the transcoder as a service. Right. So what we're looking at is a screen from the transcoder service. So without the transcoder service, what will happen is I'll have to launch a machine, an EC2 machine, which will run 24/7 maybe. So which will run 24/7, and then the data here. Anytime anybody puts data here, the system pulls and converts data and puts it back into another destination place. And I'm going to have a lot of dry runs. Dry runs means the system is turned on and it's not doing anything. Nobody's going to put data 24/7. Right? So I might get traffic to this server only for some 2 hours a day, combined. Right? Combined for the whole day, it would be just 2 hours. So it's not wise for me to run a full-blown machine, and 80% of the time it's sort of idle, but more than 80% of the time it's sort of idle. So we have a service that can, where is it? Right. So we have a service that can take in the data and sort of convert it. And so that's number one. That's number one, platform as a service. And there are a couple of other platform as a service we will discuss. The second one after the transcoder is a simple notification service. All right. This is again a platform as a service. It can intimate us through an email or through an SMS. Just like the name says, it's a notification service. If something goes wrong, if something, it doesn't have to go wrong, even if it is an alert, right? We still can be alerted through SNS, simple notification service, through email or through an SMS. Through an SMS only if it is a registered US number, right? At the moment, they don't send SMS to any of the numbers belonging to other country. They have some restrictions there, right? So let's uses that and broadcast information to the email address or SMS, and we get to know. Anytime the CPU goes high or low, we get to know, right? So what's the other one here? All right, so there are two other application as services. They are simple email services. This is if a transaction is successful, right? If we have provisioned something and we were successful, we can use this tool with some preset templates and some alarm points, and we can use this tool and then trigger email to our customers. These are not status, and these are not emails about status of the device and an action required, this, that, but just a tool to update customer through email. This can be very much interactive with the other applications that we have in Amazon, and this really helps, right? And the last one that's recommended in the book is simple queue service. Right? This is another success model in the cloud where two processes can communicate with each other even if they're sort of offline. All right, so we have introduced a queue or a cache in between two servers. So in this case, it's a web server and a processing server. All right, web server is a thin server, and processing server are 3 servers. All right, so anytime the web server gets a request, it passes that information to the queue, hoping that it will reach the process server. All right, the process server is not directly connected to the web server, which means the process server could be in maintenance for some reason. All right, so this could be in maintenance for some reason and it is down. And so that doesn't mean that the web server will have to wait for all the time to all the time for the server to come up. Until that time, keep dropping the packets, making it unavailable for the user. So we have introduced a queue in between. The request can stay in the queue for 14 days. Right. So anytime the web server receives a request, it places that request in the queue, and then it goes to interact with the user, pick another task, and then that goes into the queue. It sort of stays in the queue, and then it gets processed, and then the processed information is put in the response queue, and then it reaches the web server, and then it reaches the user. Right. Now you might have a question, what will the web server do to maintain session? So the applications that are running in the web server, let's say .NET, so they will have to have a different